All right, for years now, one single architecture has absolutely dominated the world of AI. But what happens when a new challenger steps into the ring, and its big advantage isn't more power but a totally new kind of memory? Well, you're about to find out. This is the story of a revolution that might just be getting started.
You know, it's kind of wild, but this quote is from way back in 1787, and it perfectly sets the stage for what we're talking about today. The researchers who built this new AI model, they actually put this right at the start of their paper. Why? Because in the world of AI, the dance between attention and memory, well, it's everything.
Okay, so to really get what's so new and exciting here, we got to take a quick step back and look at the reigning champ. And for the last, 7 years, that has been, without a doubt, the era of the transformer.
When the paper Attention is All You Need dropped back in 2017, it wasn't just another small step. It was a massive leap, a complete paradigm shift. I mean, think about any big AI name you know. ChatGPT, Gemini, you name it. They all stand on the shoulders of this one foundational idea. It's the absolute backbone of modern AI as we know it.
And here's the beast itself, the diagram that basically redrew the map for AI. Now I know it looks super complex, right? But the core idea was actually a radical simplification. It just tossed out the old way of doing things, processing text one boring word at a time, and swapped it for something way more powerful. And it all hinged on one key concept. And that key concept is called self-attention. This is, without a doubt, the transformer's superpower. So what is it? It's basically a way for the model to look at a whole sentence at once and figure out how every single word relates to every other word. So in a sentence like, the robot picked up the ball because it was heavy, self-attention helps it realize it means the ball, not the robot. It can connect the dots between any two words, no matter how far apart they are. That's the magic trick.
But, of course there's a but. Like every superhero, the transformer has its kryptonite, a hidden weakness. And it's a really fundamental flaw that's been holding back what these AIs can truly do.
So here's the catch. That amazing self-attention superpower, it comes with a massive price tag. See, for every single word you add to the text, the model has to compare that new word to all the other words that came before it. This means the amount of computer power you need doesn't just go up, it explodes. It's what we call a quadratic scaling problem, and trust me, it gets out of control really fast. Let me just show you.
Okay, wow. This chart just lays it all out there, doesn't it? Look at this. We start with about 500 words, and we're using around 300 megabytes of memory. Fine. But then we quadruple the text to 2,000 words, and the memory shoots up to over 4 gigabytes. Then double the text again to just over 4,000 words, and you're looking at a staggering 17 gigs, just for attention. This, right here, is the massive bottleneck we're talking about.
So here's the best way to think about it. Imagine a genius with a perfect photographic memory, but it only works for the last 5 minutes. Inside that tiny window of time, they remember every single detail with perfect clarity. But the second something is 6 minutes in the past, poof, it's gone, completely forgotten, like it never even happened. That's a transformer.
So, this memory problem, it's the puzzle everyone in AI has been desperately trying to solve. And now, a team at Google is proposing a really radical solution with a new architecture called Titans. So this begs the question, right? What if you didn't have to make that trade-off? What if an AI could have the best of both worlds? That perfect, high-definition short-term memory of a transformer and a massive, efficient long-term memory, kind of like ours. And this is exactly what Titans aims to do. It's a tale of two memories. On one hand, you've got the standard transformer, which is all about that super detailed but very limited snapshot. On the other hand, you have Titans, which bolts on a whole new component, a neural memory module that acts like a long-term memory. It's designed to learn what's important, store it, and bring it back up later. All right, let's take a look under the hood. So that main path down at the bottom, you can think of that as your standard transformer. That's the short-term memory doing its thing. But the real game changer is that separate branch up top, the neural memory. That's the big idea. It runs alongside the main model, kind of like a coprocessor, constantly watching the data stream, figuring out what's important enough to remember, and then feeding that crucial long-term context back in when it's needed. So, how does this new memory actually learn what's important? Well, it's pretty cool, and it's actually inspired by how our own brains work. First, it looks for surprises. Anything that doesn't fit the pattern, anything unexpected, that gets flagged as potentially important. Second, and this is huge, it actually updates itself on the fly.
It rewrites its own brain, so to speak, to bake in that new, surprising information. And third, it knows how to forget. Just like us, it has a system to let old, useless memories fade away so it doesn't get cluttered.
Okay, so that all sounds amazing in theory. But the billion-dollar question is, does it actually work in practice? This is where the rubber meets the road. It's time to put this thing to the test.
And to really test an AI's memory, there's one gold standard challenge. It's called the needle-in-a-haystack test. The idea is super simple, but incredibly hard. You take one tiny, crucial piece of information, the needle, and you bury it deep inside a massive wall of text, the haystack. Then you just ask the AI to find it. It's a brutal but effective way to see if an AI is really comprehending long texts or just bluffing.
And wow, the results are just absolutely stunning. Seriously, look at these charts. On the bottom, you have the size of the document getting bigger and bigger into the millions of words, and on the side, you have how accurate the model is. And you just see model after model, even the big names you know, they start okay, but as the document gets longer, their accuracy just completely tanks. It falls right off a cliff. But then, look at that red line for Titans. It just stays up there. It's just cruising along with super high accuracy, even at lengths that were basically science fiction until now.
And just to put some hard numbers on it, check this out. On a test with a 16,000-word document, which isn't even that long for these models, other cutting-edge AIs like Maba 2 got a big fat 0. Zilch. They completely failed. Meanwhile, the simpler Titans model got over 80% right, and the full-blown Titans architecture, it scored over 95%. I mean, come on, the difference isn't just big, it's night and day.
Okay, so this is clearly more than just a minor improvement. A performance jump this huge really signals a fundamental change in what we should expect from AI going forward. And you've got to understand, this is not just about being able to feed an AI a longer PDF. The real breakthrough here is moving away from just recognizing patterns in a small window to something that looks a lot more like real long-term understanding. We're talking about an AI that could read an entire novel or a whole series of books and not just spit back facts, but actually track how a character grows, understand overarching themes, and build a genuine, lasting comprehension of the story. So let's boil this all down. What are the big things you need to remember? First, Transformers, for all their power, hit a hard wall when it comes to memory. Second, Titans gets around that wall by adding a new kind of long-term memory that's inspired by the human brain. Third, as we saw in the tests, this gives it a frankly massive advantage when it needs to remember something from way back. And finally, this isn't just a small step. It could unlock totally new abilities for AI, like complex, long-form reasoning.
And that leaves us with one last kind of mind-bending question to chew on. For the entire history of AI, we've been the ones in control of its memory. We could always just hit the reset button. But if we actually succeed in building an AI with a true, persistent, long-term memory of its own, what will it decide is worth remembering? About everything and about us?